section 13.3. Again, 13.3 from the book, 14.3 in your math lab. And this chapter is going to begin talking about really the Pythagorean theorem is where this section is going to focus. And so we're going to jump right in. I'm going to try to move through this pretty quickly. So the first thing we need to know before we can understand the Pythagorean theorem is we need to know parts of a right triangle. And we mentioned this a little bit back in, I think, chapter 12 maybe. We talked about the hypotenuse leg theorem, or the hypotenuse leg property for congruence. And so we did mention these two terms. The sides A and B that you see here are what we call the legs. Now, again, this is for a right triangle. That's key because as we go through this, we talk about the Pythagorean theorem, it deals with right triangles. Okay, so you see the right angle there at the bottom of this triangle. And so sides A and B are considered the legs. Side C is what we know as the hypotenuse. Okay, so as we talk about the Pythagorean theorem here in a few minutes, we have A, B, and C, and again, C is the hypotenuse. Okay? Now, it says, given a right triangle with legs A and B and hypotenuse C, C squared is equal to A squared plus B squared. That is the Pythagorean theorem. You need to make sure you know this. This is probably the most common or the most famous theorem that we use in geometry. Most everybody has at least heard of the Pythagorean theorem. And so it says that A squared plus B squared is equal to C squared. And so let's try this. If side BC, so that's this one, right? Side A. If it is 3 centimeters and side AC, which is this one, is 4 centimeters, what's the length of AB? So what's the length of side C? So if we use this Pythagorean theorem, A squared plus B squared equals C squared. Well, A is 3, so it's 3 squared plus B, which is 4 squared. It should be equal to C squared. And so we can just do a little calculation here. So 3 squared is 9. 4 squared is 16. And that's equal to C squared. 9 plus 16 is 25. It's equal to C squared. And then to get C by itself, because again we want to know the length of C, you take the square root of both sides. Radical and power cancel. It's the square root property, if you're familiar with that from college algebra. And you find out that C is equal to 5. Now, I will point out the algebra issue here. If you're familiar with the square root property, you know it's actually the positive or negative square root of 25, but you can't have a negative side length, and so we don't consider the negative. Okay, so we only consider the positive part of that. Square root of 25 is 5. And so we find out that it is 5 centimeters. Again, don't forget to put your centimeters. I left it off, but make sure you put your unit so we know what we're talking about. That is how the Pythagorean theorem works. Okay, hopefully that's something that you can do without a whole lot of issues. This triangle is a special type. It's what we call a 3-4-5 triangle. This kind of triangle is used a lot. For example, in construction. If somebody's building a house and they need a room to have a right angle at the corner, right? Hopefully the room that you're in, wherever that may be, is in the corner, you're going to have a right angle. Well, a lot of times what a builder will do is they'll figure out where the corner of that room is going to be, and they'll stretch out a string that's 3 feet long, and they'll stretch out one that's 4 feet long, and then they'll have one that's 5 feet long, and that 5-foot piece should stretch across from the ends of the others. And it forms, if that happens, it has to form a right angle because it is a standard 3-4-5 triangle. Now, there are some other types. That's a really common one that we see a good bit. In fact, some of the next examples that you're going to see are going to deal with similar type triangles. Here's another place where the Pythagorean theorem is used a good bit. You may or may not know this, but when you go buy a TV, the length of your TV is not the horizontal length. That is not the length of a TV when you buy it. The measurement that you buy your TV based off of is the diagonal measure. And so when they say, oh, this is a 50-inch screen, well, the diagonal is 50 inches. Not that it's 50 inches wide. Okay? So be aware of that, because let's say, again, we'll talk about construction for a second. Let's say you're building a house and you have this spot that you want this huge TV to go on the wall. Let's say it's over a fireplace. My TV's over my fireplace. So let's say you want it to go over the fireplace. Well, if you go to put that TV over that fireplace and you have measured the width across that fireplace, and you said, oh, well, I can put a 70-inch TV here. Well, you actually could put a different size, because that 70-inch that you're talking about is the diagonal. And so maybe you can have a bigger size. Or if you were to build a spot, within cabinets or something for a TV to kind of sink into the wall, well, you may have this, you may say, well, I need it to be a whatever size TV, so it needs to be this wide, but maybe you don't take into consideration the height and the diagonal being that actual measure, and so your hole is not the right size. So there can be a lot of issues there. And so when you look at a TV, it is measured in a diagonal length to give you that screen size. And if you think about it, it makes sense from a business perspective, because if I can tell you that you're getting a 48-inch TV, and you think, oh man, 48 inches across, that's huge, that's 4 feet. But actually that 48 inches is this direction. Well, now I've actually sold you a shorter TV, a smaller TV, but you're happy with it because you think it's a 4-foot TV, right? And so, anyway, just to kind of give you an illustration there, that is how TVs are measured. So in this case, we have the size of a rectangular TV screen is given from these links. It is 24 inches wide, it's 18 inches tall, and we want to know what is the length of the diagonal. Well, again, we know a TV should be a right angle, hopefully. And so if we use the Pythagorean theorem, again, it's 18 squared, that's our a squared, plus b squared, which is 24 squared, should equal c squared. Now, you'll obviously want to use a calculator here to crunch some numbers. So as you do, 18 squared is 324. 24 squared is 576. And that's equal to c squared. And then if you add 324 to that, you'll get 900 is equal to c squared. And then again, you need to take the square root. And so when you take the square root of 900, you're going to get, and I'm using a calculator just like I expect you to. So let's see if I can get mine to do right. There we go. So 900, we're taking the square root, and we get 30. Now, here's something that you maybe could have noticed. If you notice that 18 and 24 are both divisible by 6. Well, 18 divided by 6 is 3. And 24 divided by 6 is 4. Well, that's your 3, 4, 5 ratio, right? So whatever this c value is divided by 6 needs to be 5. So 5 times 6 is 30. C has to be 30. So you could have known that without going through all the calculations. Now, I've shown you the calculations because I wanted you to see how we get each number, but you could have very easily found that in your head if you knew that the 18, 24, and then that C value were going to be a multiple of the 3, 4, 5 triangle. Okay, in this case, multiplying it by 6 gives you the 18, 24, and 30. Oh, and I was trying to not write there. There's our stuff. And so again, you can see that's exactly what we did to find the 30. If you have any questions about that one, let me know. A lot of times if I notice that numbers, if I divide, I could get to a 3, 4, and possibly 5 triangle, then I'll a lot of times try to do that instead of working through this with these bigger numbers, because I can do that in my head. And so that's the way I would do this one. But again, the algebra part of it is here. You can see all of that. Now, look at this one. It says a pole BD, so maybe this is a light pole, is 25 feet high. It's perpendicular to the ground. 2 wires, guard wires, are attached to be A and BC, and they're 35 feet long. Again, you can see that in the diagram. And they're attached to the top of the pole and staked at points A and C on the ground. If points A, D, and C are collinear, okay, so they're all on the same line, how far are the stakes A and C from each other? Now, like I mentioned in the previous problem, I noticed really quickly that 28 and 35 are both divisible by 7. And so 28 divided by 7 would be 4, and 35 divided by 7 is 5, which tells me that 3 times 7 should be this side, which is 21. And so AD, because again, this is a multiple of the 3, 4, 5 triangle, AD has to be 21 units. Now, let's say you don't know that, because I don't want to assume that you would recognize that. So let's say that A squared plus 28 squared is equal to 35 squared. Well, we know A squared plus, again, need to figure out 28 squared. And so again, use your calculator. So 28 squared is 784. And then 35 squared is 1,225. And then we need to subtract 784. And we get A squared is equal to 441. And when you take the square root of both sides, you find out A is equal to 21. Now, that's what we said just a second ago. All right, we said that this side should be 21, but that is not what the question asks. The question doesn't say how far is A from D. The question says how far are stakes A and C from each other. Well, if BC is 35 feet, you've got the same measurements. So that means that DC, this length, must be the same as 80. And so it's also 21 feet. And 21 plus 21 obviously is 42 feet. And so there is our answer for that one. And again, I wrote right over the top of that, but that's okay. You can see the 28 squared plus DC squared. It actually did it on this triangle instead of the one to the left. I use the one to the left, but it's the same thing. And you can see how the DC is 21, and so AC is double that, and so that's where the 42 came from. If you have questions about any of that one, let me know. So let's look at this one. This one is a little bit different. So this one says, how tall is the Great Pyramid of Cheops? So the right regular square pyramid. If the base has sides of 771, and again you can see that there on the diagram, and a slant height of 620. Now, the slant height, the slant height is this length. It is the height of the triangle on the side. It's called the slant height because it's slanted, obviously. But it is that triangle on the side. It's the height of it, or the altitude of it. Okay? And so, to find the height, we're really looking at this triangle here. So you can see that right triangle. And that's when we're wanting to find EF. We're wanting to know this side length so that we can figure out what is the height of this pyramid. Now, to do that, a couple things we got to take into consideration. If this is a square pyramid, and it's a regular square pyramid, this point E is directly over the center of that square, which means that FD, this length, is going to be half of 771. Now, if we use a half in our calculations, it's obviously going to give us a decimal. Okay? So, we can approach this a couple different ways. So, first of all, 771 divided by 2. 771 divided by 2 is going to be 385.5. Okay, and we can use that as we go through our calculations. Now, I'm going to show you what they have on the slide, just so you can kind of walk through it, and that way I don't write over it and make it hard to see for you. So, FD, which is what we're talking about, is half of AB. Okay, again, we know AB is 771, and so again, we have this 385.5. And so if we follow the Pythagorean theorem, that squared plus this missing side, the one we don't know, has to be equal to the 620 squared. And so you just punch those things in. You can see that here. And then as you continue to do your calculations, you do end up with a decimal here, which is not a huge problem, but it is something that we end up considering. So just to kind of, because the slide doesn't show all the little details, I'm going to call this side that we're missing B. So we've got the 385.5 squared, that's going to be our A, plus B squared equals 620 squared. And again, as you punch in all those numbers, so 385.5 squared, it's going to be a really big number, and that's why these numbers are not used necessarily here, but it's 148,610.25 plus B squared, and then 620 squared is an even bigger number. It's 384,400. And then if you subtract the 1,048,610.25, then you end up with this number here. Okay, so when you subtract this, 148, 610.25 on both sides, you get b squared is equal to this. And then when you take the square root of that, you get this number. And again, it's an approximation. It is not going to be an exact number, but it does give you a pretty good idea about how tall this pyramid is. So we would say this pyramid's 485.6 feet. And that's an approximation rounded to the nearest tenth. If you run around to the nearest foot, you would say it's 486 feet. But obviously, the more decimals you use, the more accurate that measurement is going to be. If you have any questions about that one, let me know. Again, what makes this one kind of difficult is that the numbers get so big, and you're also dealing with a decimal there. You could have used a fraction. I don't recommend that, especially if you're going to punch this in the calculator. The fraction would be quite difficult to use. If you have any questions about it, let me know. I'm here to help you as you need it. So again, you see our statement there at the bottom. 486 feet. Alright, so tell you what, I'm going to stop this video. I'm going to come right back with another video about special right triangles. There are a couple different ones that we need to talk about, but this is going to push this video longer than I want it to go. So I'm going to stop here. I'm going to pick right back up in our next video with this slide.